Dear students, in last class you have studied the factors to be taken into account while selecting a site for nuclear power plant. Today you will be learning the block diagram of nuclear power plant using a heat exchanger. A nuclear reactor, heat exchanger, steam operated turbine, coupler which couples turbine to the alternator, three-phase supply, condenser, cooling tower, circulating water pump, condensate water pump, heater and feed pump. If you look at this block diagram, you will understand that there is very much a similarity between the coal-fired steam power plant and nuclear power plant. The main difference is, instead of a boiler, a reactor and heat exchangers are used. All other parts or all other components are same here. And one more major difference is the safety. The safety against the nuclear radiations. In construction of nuclear power plants, utmost importance is given for the safety of the operating personnel as well as the people who live around the nuclear power plant. Here we will not be studying the atomic physics to understand the working of nuclear power plant. For us, in this block diagram, nuclear reactor means a container in which nuclear material is placed and that nuclear material undergoes fission reactions and lot of heat energy is released during this fission reaction. That heat energy is extracted using coolant a coolant material is passed through the nuclear reactor and the coolant takes out the heat from the reactor, and that coolant transfers the heat to the working fluid, which is usually the water. In the heat exchanger, when the water gets heat energy from the coolant, the water gets converted into the steam, and that steam operates the turbine. Since turbine is connected to the alternator rotor starts to rotate and the mechanical energy is converted into electrical energy. The steam coming out of turbine goes to the condenser, and from there it goes to the cooling tower until the steam gets converted into liquid water. The water is circulated between condenser and cooling tower using a circulating water pump. Once the steam coming out of turbine gets converted into water, it is given to the heater by the help of condensate water pump. A condensate water pump is used here because when the steam is getting converted into water, the pressure dies. So at low pressure, it is not possible to send the water into the heat exchanger. So a condensate water pump is used which can force the water into the heat exchanger. But before sending the water into the heat exchanger, the water is heated once again here. When that condensate water is heated, the pressure increases, and that pressure is further increased by using feed pump. So, working fluid cycle is completed through heat exchanger, turbine, condenser, condensate water pump and heater. Whereas the coolant flows between reactor, heat exchanger only. So this is one closed loop here that you can see, and here is another closed loop that you can see. A nuclear power plant is almost similar to the coal-fired power plant except the steam generation part where nuclear energy is used for the steam generation. Some safety devices are also used. The basic circuit of a liquid coolant nuclear power plant is shown in figure above. The boiler of conventional steam power station is replaced by the nuclear reactor and the heat exchanger. Reactor is the main part of nuclear power plant where a coolant is used to generate the steam to run the turbine and thus electricity is produced. Main components of reactors. As already discussed, in nuclear reactors, nuclear material is placed which undergoes fission and produces huge amount of heat energy, and this heat energy is used to generate electricity. So nuclear reactor may be regarded as a furnace. It may be regarded as a furnace wherein the nuclear reactions will take place. The nuclear furnace is termed as a reactor or pile. The purpose of a nuclear reactor of power plant is to produce electricity. A mass of fissile material such as uranium is inserted into the core of reactor. This fissile material when undergoes fission, lot of heat energy is liberated. Due to this heat, the core of reactor heats up. To cool the core and remove the heat so that it can be used to generate electrical energy a coolant is run through the system and taken to a heat exchanger which removes the heat to a separate system. It is then used to generate steam which runs turbines which in turn drives electric generator. Next we'll take Fibel rods. The Fibel rod is a tubular structure made up of zircaloy, and this tubular structure is filled with pellets of uranium. These Fibel rods can be lifted into and out of the reactor mechanically, allowing fuel replenishment while the reactor is in operation. It means that when nuclear reactor is in operation, if the fuel is to be replaced, then we can take the fuel rods outside and take out the old nuclear material from the fuel rods and then insert new material. After that, once again introduce the fuel rods into the core of the nuclear reactor. A fuel rod is zircaloy tube filled with pellets of uranium. These fuel assemblies can be lifted into and out of the reactor mechanically, allowing fuel replenishment while the reactor is in operation or in service. Shielding. Shielding is used to give the protection against alpha, beta and gamma radiations. Which are emitted during the process of fission in reactor. During the process of fission in reactor. Moderator. A moderator is used to slow down the neutrons released during fission. The material used as moderator may be graphite, heavy water, or beryllium. For natural uranium, if natural uranium is enriched, then ordinary water can be used as moderator. And you know that by slowing down the neutrons, the number of collisions can be reduced with the nuclear material, and hence the energy released can be reduced. A moderator is used to slow down the neutrons released during fission. Graphite, heavy water, or beryllium can be used as a moderator for natural uranium. However, ordinary water is used as moderator with enriched uranium. Sometimes what happens is excessive energy will be released in a nuclear reactor, and because of excessive heat energy released in a nuclear reactor, the Fibel rods may melt, the coolant may be disintegrated, and the nuclear reactor itself may be destructed. So in order to avoid such situations, having control over chain reactions is very, very important. So to have the control over chain reactions, control rods are used. These control rods absorb the neutrons when inserted into the nuclear reactor. If the neutrons are absorbed, then the number of neutrons reduces in the nuclear reactor taking part in chain reactions. Due to the reduction of these neutrons number, the heat energy released reduces, and hence the Fibel rods, coolant, and the reactor will be safeguarded. For making the control rods, Materials such as boron carbide, cadmium or hafnium are used. To prevent melting of fuel rods, disintegration of coolant, destruction of reactor due to excessive heat, energy release. Control the chain reaction at steady state value during the operation of reactor. It is necessary to have controls. Chain reaction can be controlled either by removing the fuel rods or by inserting neutron absorbing material. These rods are made of boron carbide, cadmium or hafnium, and are inserted from the bottom of the core to absorb neutrons. which controls the rate of fission additional main control rods are inserted from the top down and provide automatic or manual emergency control. In next class we will study coolant, steam separator and containment. Thank you.